Dear students, I welcome you all for this special online lectures for the practices component of industrial robotics. So today, this presentation will take us to the pick and place program. So the task for pick and place is like this. Program an articulated 6-axis robot to move along a path to pick and place a part from one point to another point. Okay, so before we get into this, we should understand some basic fundamentals. Okay, what all are, or who is the member going to take care of this pick and place? So default there is an element called as gripper, or another case called as EOAT, also called as end effectors. So these all are the basic elements which are going to help us to pick and place a part. Now, the term pick and place is very generic, but engineering term it is not so. So it is different. So what is the thing is grasping and releasing. So these all are the things what we should know. So grasping means holding. So it is going to hold the part, and releasing it is going to leave away the part. So these all are the technical terms, grasping and releasing. So what is this grasping function? What is this releasing function? So now we'll see with a very simple example. Now for example, there is a two-hand gripper. Now this is the two-hand gripper. Now there are two conditions are there. So this is condition number 1 and this is condition number 2. Now what does this condition specify means? This is in open condition. Now the gripper is in open condition and this means the gripper is in closed condition. So open condition will facilitate releasing. So release action will take place and here grasp action will be taking place. So this is what the basic. So now what is the command to release or what is the command to grasp? So that has to be known very carefully. So now there should be a member to do this task. No? So the command is like this. So M underscore out 15 is equal to 0. Okay. So now we'll decode this. So M means machine function, underscore out, that is it is going to send some signals. So through which by the port number 15. By port number 15 it is going to send signal. When it is 0, then this condition is the release condition. Release. It is going to release everything. So this is 0, false condition. Now what is the true condition? M underscore out at the port 15. See, always it is 15. Okay. So usually it is for gripper action. So is equal to 1. So 1 means true. That is, it is going to grasp. It is going to grasp. That is, 1 associates to this particular case. So 1 means this particular case. So 0 means release case. Okay. So this is the first concept. Now we'll go for the next concept. And now there is a part. For example, there is a part. Now this is the gripper. Somewhere it is at the home point. So now this point is called as TCP, tool center point. Okay. Or gripper tool center point, GTCP or just TCP. So this is the point where the part is there. So how the robot should come means, what is the trajectory is? The trajectory is like this. It should come exactly on the top of the workpiece. So somewhere it is supposed to come here and then it should decelerate vertically. Downwards it should decelerate in a perfectly straight motion. Then after reaching the path, what it's supposed to do is, it is supposed to hold. That is grasp. So here there is a point and this point is called as safety point. Okay, it is called as a safety point. So for understanding, we'll just name it as alpha. Okay. So how to do this program? Why? Because usually we give this point, say P home point is there, and this is the picking point, say P1, and somewhere you wanted to place P2. So these all are the 3 points what we define in the declaration point. That is point declaration or point definition. But here what is the thing is, here we have got another point, say P alpha 1, and similarly here there is another point called as P alpha 2. So these all are the deceleration points. So how to define them? It is not our task, but it can be programmed nicely. So now we'll start with this basic understanding. We'll start. So how do we do the program? So move P home Now it is okay. Now we don't know what is the gripper condition, whether the gripper is in open condition or in a released condition. So always we are supposed to give away that particular command first. So m underscore out at the rate of 15 is equal to 0. So if the gripper is in closed condition, what will happen is this will be opening. So students, often I emphasize this is 0 and this is O. Okay. So it is not caps, it is regular, that is a small case only, but M is caps. So this is 0. So please be very cautious enough. So now what is the thing is, we wanted the robot to come to the P alpha 1 point. So that is this point. So we wanted the robot to come to this point. So now what we'll do is, we'll write the command like this. MVS, okay, P1. Now directly it will go to P1. That's what we think. No, comma, minus 100. Okay. So don't worry about this minus or plus. Always it is minus only. Always it is minus. Okay. Now what is the understanding is, now this is the point P1. This is the point P1. So minus 100 point is this point. Okay. So let me name this as point alpha 1. So somewhere P home, the robot is. So when you define like this, what exactly happens, what the controller decodes or what it instructs the robot is like this. So wherever the point P1 is there, above the point, okay, it is not plus, always minus. Above the point by 100 mm, have a point called as alpha 1. This point we need not to define. So default minus 100, that is 100 we can change, but minus means on the x-axis only. It is not going to take any other thing. So now we know the gripper is open, it is above the safety point, and now what is the next thing? It should decelerate to P1, move PS, move, that is MVS P1. Now the robot hand will come there. So after coming over here, what is the thing is, we want the robot to hold the part. So M underscore out at the rate of 15th port is equal to 1. So now what happens is, grasping action is going to take. Okay. But for the case of grasping, should we give some time? So therefore what we'll do is, we'll give delay. Okay. We'll delay by 1 second, some 0.5 second, but 0.5 is not very small, negligible, by delay by 1. See, now the robot has is lifting some part. Okay. So at least some grams, right? So we should reduce the speed. So how do we reduce this? Override OVRD 50. That means 50% of the set speed it will be coming down. So now the robot has picked, it is supposed to place in the P2 point. And this is alpha 2 point. But now where is the robot? The robot is, it is here. So from here, it should directly come over to this particular alpha 2 point. Sorry, this is not 1, this is 2. Alpha 2 point. So how the robot will come to alpha 2 point is MVS P2, comma minus 100. So from here, obviously it comes over to this particular point. Clear? So now it should decelerate here to this P2. So MVS P2. Now it decelerates. Now what is the thing? M underscore out 15 is equal to 0. So now what will happen? Releasing action. So now the robot is going to release the part. So once it has released, we need not to have this override. So override is 100. Suppose, sorry, it is 100. Here, obviously we should have a delay by 1 second. So once the delay is over, now this is override by 100. Okay. So that is, you go back to the original statement. So now what I'm doing is, this from here to here is the main program. Okay. So I'm just going for the next slide. I want this task to be done, say for 10 times. See, whatever the task we did in the earlier case, this particular case, okay, I wanted this to be occurring 10 times. Now what can we do? Think of what can we do. Now we have got two options. So first option, I will go for far. For far, same everything in the previous, immediately after this P move home, after this, okay, not this, let me erase this. So this point, say from here to here till this end. So what we'll do is, I am using for condition, okay. So here M0 is equal to 0, we need not worry here because I'll start from 1. For m0 is equal to 1 to 10. So I want you guys to recollect for the moment for comes immediately next to should be there. Okay. So here you paste all this the activities, whatever the thing we did there. So once everything is over, here you can give next, and finally you can give it as move p home. Okay. This is using the for then. Now if then, same statement, it is very simple. Okay, you need not to worry about it. First, what is going to be the opening statement? We know the opening statement is move p home default. So whenever you do if then, counter. So m0 is equal to 1. Okay, I'm not starting this time, I'm not starting with 0. Even if I start 0, I will close at 9. Since I am starting at 1, I will go till 10. Then what is the next step is asterisk. You can give me. See, always that do not mean that you need to give only anything you can give. Okay, then you can give the program. So here the program is going to be there. At the end of the program, we are going to give the counter. m0 is equal to m0 plus 1. Then here you give the count condition. If m0 is greater than or equal to 10, then see here last time I didn't tell, even you can use this, then go to, even you are not using, no harm in it. Then asterisk, it will be ME22710. So last will be move p home. Okay, so this is how we can add looping program to the picking and place program. See, anything we can do. Only thing is the headers and footer. This part you should have clarity. Okay, so with this knowledge, I am closing down this particular presentation. Thank you, students. Thank you all.